Today we're starting a project that's a little bit different. We're going to be replacing a gas boiler at this apartment block and replacing them for energy efficient air source heat pump, all thanks to the 7,500 government grant. For developers and landlords that own properties like this is the perfect opportunity for you to take advantage of this government grant and upgrade the homes that you own, making them more efficient whilst also raising the price of them in value. Today we're going to be showing you how we install these heat pumps.
This will go here and this will come down.
So if it's something that you're interested in, make sure you subscribe now.
The boiler, these are all the pipes here. I'm going to get the cylinder in place. I'm going to change these pipes to 22mm for the cold and the hot. Reduce them down into 15 into this ceiling space. Move these over here so that they can come straight down for the buffer, which I'm going to have situated up here. These ones are going to change to 22 just because all the fittings on the cylinder, as well as the shut off and something called the Calafi valve, they're all in 22mm, so all of this is on show left in 22 for a metre before it then goes to all your taps and bathrooms. And then I might get the heat pump pipes out at the back, straight for the heat pump here, or I might have them coming through here above it, which might be a bit easier. I want at least the hot and cold's done for here. Hoping to get the buffer on the wall and maybe one side of the buffer done to drill through for the pipes for all the heat pumps so that I can finish it off, but we're not going to get that on until tomorrow, so as far as today's done, probably just most of the cylinder done except from the heat pump pipes, and then half of the buffer done today. So I'm just trying to map out where my Calafi valve is going to go. Then I'm going to have the lever arm here. I'll have a T at the bottom here with a drain off on the bottom of it. So if we ever need to drain the cylinder, we can drain it straight from there. We get all the cold and hot water out of it. Cold pipe in, got lever valve on, so if it ever needs shutting off, you shut it off there. This is the Calafi valve in place. This side's going to get capped because it's not getting used to reduce the pressure down to 3 bar. We have a pressure relief valve here, just in case it ever fails, so it can release the pressure. This will meet up with this pressure relief valve just in case it ever gets too hot or pressurised in the cylinder. It lets out a load of water. This will come down into a ton dish. You'll see the water dripping if it's ever failing, so you'll know this is either broken or this one. So then that will go straight outside and down, and a drain point here for the cylinder, just in case it ever needs to be drained. And at the minute it's just getting the bracket prepared for the heat pump to go on the wall. So he's just marking it up and trying to size up everywhere it's going to go. Just getting the legs all ready for the heat pump to go on the wall. Me, I'm going to tighten everything up, and then I'm going to get the hot pipe down and get the expansion vessel somewhere for it. Right, so we've got the cold pipe in, we've got the hot pipe in now into an expansion vessel to allow for the rise and fall of temperature, stop it from exploding. So that has like a little rubber line on the inside of it top half is air, bottom half is water, and then when it rises, the bladder or the rubber expands up towards the air and allows for the settle of like the hot to cold. They've cut the hole outside ready for the bracket to be placed on the wall. We're just going to get some thunderbolts, which are some thick concrete screws, which is going to hold the bracket to the wall, allowing the heat pump to sit on it comfortably without any worries of it falling off. Next step now, measure up for the buffer to go on the wall, just make sure everything's going to be okay. We're going to use the old flue hole to get the heat pump pipes in, and it'll have a filter in return. Stops getting any rubbish into the heat pump, stops it from, you know, having like little bits of iron filings and stuff going into the heat pump, protecting it. It has a flow gauge on it as well, just to check your flow rate, make sure everything's okay. And it'll have a filling access on it that allows us to fill up with glycol. Top of the buffer is an air vent, which allows the air to come out of, you know, the system, stops it from locking out, because when there's too much air in the system, the heat pump will lock out and it will just completely shut off. So that allows for the air to escape without having to bleed, you know, certain things by hand. The return to the heat pump outside, and it'll have a filter in the return. On this side, we're going to have the flow to the heat pump outside. This will have a flow gauge on it. Flow's always at the top, returns at the bottom. These will go straight up and connect into these 3-foot pipes up here. On the flow, there's going to be a pump which helps draw the water from inside that tank actually to the radiators, because without it, it would just sit in there and it would just keep getting hot into here and won't pull through. These to some angled irons so that we can get it as tight as we can for the cupboard. And these are going to connect into this side here using a 3-port valve, which diverts it from using the hot water. Can also change to do the heat inside, so this will go here and this will come down across. Pump, run flash pump, got an arrow flowing of direction. So I'm going to put this on the flow. So our arrow's coming in from the heat pump here, up that way. So I want my arrow pointing straight up so that it'll pull it out and go to the radiators. The electrician can come and wire it in. These pumps have like 3 different settings on them. So by clicking that button you can check the speed of it. We usually leave it on the highest setting so that we get the best flow rate, because obviously the heat pump will work a lot better if it's got higher flow rate. These little valves, either sides, are like little gate valves. These have a rubber on the inside of these that create a seal. These can be used to turn on and off by twisting them or opening them the other way, so that we can service the pump or change the pump in future if it ever becomes faulty. So everything from this side, the only thing that needs to be done now, these need to be tightened and needs to be connected up at the top to the actual radiator pipes. They just need cutting down, as well as the cold and the hot. They just need to be swept over, put onto the top of them, and then that's this live, these live. Dan's outside at the minute getting the heat pump pipes over. It's got the valves on them and the flexies into the bottom of the heat pump. So as soon as he's finished there, I can get these down into the other side of the buffer and into these that we've now put these elbowed male irons on to create a bit more space for us, which then we can fill and loop door. It's got a little gauge on it. So we top our pressure up to 1.5 bar. That's a way of checking if it's up to pressure. And also you can also check to see if you've got any leaks or if there's any faults if the pressure drops down. So this is just a paste that you put on these. These are called olives. Helps you get a better seal on it, as well as getting a tighter seal as well, so that it allows to create a barrier between the actual fitting on the inside and the olive. I've got the 3-port valve put in up here. There's 3 sides of it. You've got an A side, a B side, and an AB. AB goes to your heat pump outside. B stands for buffer, for your buffer. A comes down, primary flow here. Come down, I'm going to have the flow gauge on it, the filter on it. It's going to come to the bottom of the buffer, follow the flow, return the flow down, come along the back here, and they're going to come out straight into there. They should just be able to sit straight on there and they'll go straight back and across into there. Return pipe now has the flow gauge filter and is into the bottom of the buffer. Figure out, thinking of teeing across here, then I can come up, put the expansion vessel there. We come down there, with the tee off there, filling loop. So today, surprisingly, quite happy to say that we've got the heat pump piped up, got the valves on, got the bracket on, heat pump's on the wall, so that's a bonus. Inside, we've got everything connected up in the ceiling space, cold's done, the filling loop is connected on throughout the cold side, heating expansion vessel needs a thread on there, needs connecting in, and then the other side of the filling loop with the pressure gauge on needs to be put in. Everything needs lagging. But we've got the filter on, flow gauge, the 3-port pump, 2 air vents, 2 expansion vessels, one for the cold and hot, one for the heating. Buffer is connected up. We've got the collector valve on, and we've got 2 drain offs, one on the heating and one on the cold water. Pressure relief valve still needs to be done, but that's going to be done the next day that we come back. Quite happy with how we finished it after day 1. I was going to come back another day to test everything. Yeah, that still needs to be filled up. Everything. So the cold water is on, but it's only on till here. I've got it shut off in a minute. So once everything's completed, I can fill up the cylinder, then fill up the radiators or the heating, test everything, make sure there's no leaks, make sure everything's working properly as it should do. Then I can lag everything, lag through the wall, fill that hole, lag outside, and do the condense pipe for outside. On to day 2. Welcome back to another day, day 2 of finishing off the heat pump. We're gonna get everything pressure tested, finished off and lagged and commissioned for the electrician to finish everything that he needs to do. Change the 3-port valve so that it's easier to service in the future. Also need to hook up the red expansion vessel on the heating system and finish off the filling loop. Then I need to condense pipe outside for the heat pump and do the blow off pipe as well. That's another thing that needs to be done. And then as soon as that's done, we're good to go. I'm now getting ready to fill up, just making sure all the valves and everything's open, so that when we fill up, we know we can test everything isn't leaking. That's air escaping from the system because it's a closed system. There's a lot of air in the pipes. As soon as you put water in, the air escapes through these air vents and the one at the top of the buffer. Changed this morning, this 3-port valve, just because the angle that it was on before, it would have just been a little bit too hard to change if we ever needed to come service it. So I've changed it so the actual head is pointing out, so it'll be easy to service whenever we do.
Vessel, put female line on there, done a little bend on this pipe, leaves it on a T so that we can use it for the filling loop. Finish the filling loop on.
Then I've connected up the PRV from the Calefi valve and from the cylinder into a ton dish. Left 300 to the bottom of the bend. Then sent that outside, keeping it as tight as we can to the cylinder to keep it nice and tight and compact. We've filled the system with glycol and then we've topped up the pressure, so we've got it up to pressure 1.5 bar. Bled all the radiators, checked for any leaks. That's everything really, all completed. Pipe, you've got to make sure it's got fall on it because it's got no pressure behind it. Got nowhere for the water to go if it's that or if it's running back. You know, if it was like that, it needs to be pointing down so that it can actually run down the pipe.
Jack is finishing up. John is now wiring the air source heat pump. Inside the air source heat pump are connections for power, communication with the controller, central heating pump and a 3-port valve and a hot water tank thermostat.
Putting this condense pipe in just because it needs to be connected up to the bottom of the heat pump, because without that water will just drip straight onto the floor and in icy conditions it will just freeze and then it creates a hazard. So we need to put it into a condense pipe that's going to go all the way down into soak away into the floor down there, so it's not going to cause any hazards or anything for anyone.
Right, so right now, what I am doing, Josh, is wiring up the signal wire, which will call for heat basically, and wiring up the pump and the 3-port valve. Take it into a wiring centre in there. We're going to wire in the MIDI controller and then also the third-party controls, which I believe is a Honeywell T3R.
Why'd you put expanding for a minute, Jack?
Just so, because it was an old boiler flue, there's not cold air coming through. Stop any drafts or anything coming from the top of it, keeping it insulated. this is everything completed now. Done all the lagging, all the cable ties on it, lagged through the wall to outside. Hole has been expanding foam, so that's everything complete. Yeah, it's gone well, to be fair. We've been able to get it all nice and tight. I'm going to keep it as tight as possible and then it'll all get boxed in.
Moving on to the wiring inside the property, John has chosen to use a Wago wiring centre to make the connections to the pumps and the valves. The biggest part of the air source heat pump in the property is the hot water tank.
Heating controls come from the pump itself, like, so it'll like take factors in to switch the gear.
Welcome back to day 3 of the installation. Now, before John finishes off and commissions everything today, an inbuilt unit, the original inbuilt unit that the gas boiler used to house in. With that being said, let's hand over to John and let's commission this system. John is wiring up the distribution board for the air source heat pump system. It includes surge protection, RCBO protection for the air source heat pump, and an immersion heater and a timer as well for that immersion heater. We've also installed an energy meter. The energy meter is just a convenient way of letting you know how many units of electricity the air source heat pump has used. Within the media controller, you can see much more detail about the energy used for the heating and hot water, and of course the Scott rating. Next, John is performing the final electrical test on the install before commissioning the air source heat pump. John is testing the earthing, that the RCDs work in the required time, that there's no damage to the insulation of the cables. Finally, John is commissioning up the MIDI controller and tailoring the setup to the customer's needs.
So here we are at the end of the install. John's commissioned the system and it's up and running. We've come today to check the QC, electrical QC, all the electrical testing and the wiring, make sure it's all up to our standards, which of course it is. So with this air source heat pump, this is a 4 kilowatt model. You can provide all of your hot water, which it stores in the tank. That's for washing up, showers, hand washing, but it also provides the heating for the radiators. And because it's electrical, you can run it Octopus tariffs called Octopus Cozy, where you have different cheap time slots throughout the day. And if you join Octopus using the link in our description below, you'll get an extra £50 credited to your bill. So you can see the heat pump's on now, and the microphone probably won't even pick up the sound of the moving fan. It's so quiet. There's 2 pipes coming from the heat pump that carry the flow and return of the hot water. There's also the electrical cable that supplies the power. And then inside the flat, which we'll see later, there's a little control centre that manages whether it's the heating, the hot water, and checks the various temperatures of the water tank and things like that. Everything outside is fully waterproof, suitable in any weather condition. You might notice that on the brackets there are rubber mounts, so there's no vibrations transferred to the building, and it's it's inaudible inside the building. You can't tell if it's on or off, and even stood here underneath it while it's running, I can't hear the fan turning. A smaller air source heat pump, this is the 4 kilowatt model, we can fit up 16 kilowatts on a single phase. The electrics are essentially the same for all of them, different size circuit breakers, different size cables, but it's the same setup, the same controls. The air source heat pump monitors the outside temperature. There's a media controller inside which monitors the inside temperature, as well as a separate thermostat where you can choose what times or temperatures you like in the room. And between them they calculate the most efficient way to extract the heat from the air for use in your house. We've got the hot water tank that holds all the domestic hot water needs. expansion vessels, isolator for the immersion heater that does the Legionella cycle once a week. And it's got its own little fuse board. And in here we've got RCBOs for the air source heat pump and for the immersion heater, as well as a 24-hour, 7-day timer that controls the immersion heater and a kilowatt hour meter, an energy meter that records how much energy you've used for your air source heat pump. We've also added this cupboard to keep all the equipment tidy and out of the way. We'll be adding a door later, but just for the video we've left it open so you can see what's in here. So to control your temperature, you just use this thermostat that you can place anywhere in the room. You can set the times and the temperature you require. That communicates by radio link to this base, which then communicates through a little junction box with a MIDI controller that's also connected to the heat pump outside, and it's got various algorithms inside it to be the most energy efficient depending on the inside and outside temperature. So John's commissioned the system through the MIDI controller. Really useful device. You can set so the system's currently running now. You can barely hear anything. I think once the cupboard door's on you wouldn't even know it's running. As we saw outside, the heat pump is almost silent.
Can you hear it in here, Phil?
I definitely can't hear anything.
And that's the end of today's video. Hopefully you have found it insightful and informative. If you would like an air source heat pump fitted on your property, whether that be a house or a flat, get in contact with Blue 8 Renewables today and we can do that for you straight away. You can book a consultation in the description below, or you can head to our website, which is blue8renewables.co.uk. Thank you for watching and we'll see you in the next video. Bye bye.